Good evening to all, and very sure Happy New Year to 2021. Now, let us start the program. Before that, I would like to welcome our faculty today, Engineer T.D. Nadraja, who has retired as GM, General Manager from our HARD, Center for Applied Research, NLCIL. Welcome, sir. And I welcome all the participants who has joined physically as well as the Zoom meeting. So let us straight away, because we are late by 10 minutes, we'll straight away go to the program. And before we invite our faculty, Mr. Nadraj, T.D. Nadraj, sir, for giving the presentation on the topic, let me introduce him. So, Engineer T. Nadraj, sir, FIE, is a member of our premium institution, Indian Institute of Engineers, and he is president of ENDC, Engineers and Scientists Association of Neyveli. He has retired, as I already told, as the General Manager, Center for Applied Research and Development, NLCIL. So yes, finished his BA in chemical in the year 1982. So yes, finished his degree from in the year 1982, and he has finished his master degree in chemical in the year 1988. He is the fellow in Institution of Engineers from 2016. He has started a partnership firm, AMS Sakti Fuels, in 1983, and served for 3 years, which produced a briquetted fuel after pyrolysis of agricultural waste. He has joined, then he has transferred to HARD in 2003 and carried out works as in charge of environmental division, fuels and microbiology, soils, general analytical section, fumic acid plant, zeolite from Neyveli fly ash, etc. Filing renewal of patents, commercialization and new initiatives, lignite coal blending, briquetting, lignite to diesel, lignite to methanol, etc. etc. He has retired as General Manager in HARD NLCEL in June 2020, and still he is continuing as President ENDC and Neyveli. First, I have to thank personally for he has accepted our invitation readily for this presentation. He is a very well-known personality among our Neyveli. Actually, the introduction, biodata introduction, is only for the other people who has joined from not from NLCIL, such an eminent person. And I may have the privilege now for inviting Mr. T.D. Nadraj for presentation on the topic gasification of coal and lignite. Sir, over to Nadraj.
Okay, friends, good evening. I am seeing a lot of faces which are familiar to me, and I am very happy to be with you in sharing my experience. Right from the beginning, gasification technology and my career started parallelly. After the completion, because when I am explaining my experience, the gasification technology one by one I have experienced. So I want to share my experience, how I handle the technologies from the beginning. Initially, I was handling biomass gasification system. I have started an industry which was producing briquettes equivalent to LICO. This product, after pyrolysis, carbonization, using rotary kiln, we receive carbonized chars. Initially, external fuel was used for heating the feed. Once the gas start evolving, that gas is recirculated and that is used as fuel for incoming feed. Once the synchronization started, we will cut the external fuel. In that way, pyrolysis was agriculture based. The capacity of the plant was 4 tons per day. And after taking of the jar, some binders were added, and with the binder, it was extruded. The extruded briquettes were sent for domestic purpose. Production absolutely it was good. We have warm reception and public, but due to financial crisis, I have withdrawn myself from company. Then I joined LC. R&D. Yeah, I went to do picketing and organization plant after that. In that plant, it is mixed and moving bed gasification. So it is a vertical retort wherein feed was given from the top and the product was put at the bottom. The system is initially drying, then gasification, and then volatilization. Finally, combustion. So the 4 stages I will explain in the PowerPoint. In the fixed bed, it is a low temperature carbonization, and the process is definitely compared to entrained bed, it is cheap, low pressure. You can take out briquette, and at the bottom you will get tar and some chemicals, phenols. I was in the downstream side. I was having experience in the phenol production unit. It has vacuum systems, extraction systems, distillation process, and then middle oil distillation. So the byproduct which was having gas liquor, it has 2% phenol, and middle oil it has 14% phenol. So those things extracted 1,800 tons of phenol produced per annum. This is fixed and moving bed gasification. So next, I was in fertilizer, wherein initially Winkler gasifier was used. It was fluidized bed gasification, wherein lignite was fed to the fluidized bed gasifier. After the process, you will produce syngas. Fluidized bed gasification system is what we do in the fluidized bed combustion. Combustion and gasification both are different. Combustion is complete combustion, gasification is incomplete combustion. Oxygen is reduced. Just see the next slide. So I am going to explain as per the list given in the slides about the plant. I have explained. We have to consider the safety aspect of the plant because it's a chemical plant. It is highly risky. Always fire. Everywhere fire is there. Small fire is there. If it is a big fire only, it will be informed to the higher ups. So we try to control the fire in the chemical units. And another thing, carbon monoxide, nitrogen, those points are very harmful. It should not be inhaled. So safety precautions are also taken in that aspect also. Another point is environment. Environment, in the chemical factory, whatever you are letting out, it is a polluted item. It should be viewed suitably, and control measures have to be taken. These are all extra cost, which is not included in the project cost, but it should be included with the inclusion of this only, you have to calculate the profitability. So after all, it is a business. Always the players, I have had experience in the last 10 years with the firms who are trying to sell the technology. I don't find fault with them because they have limitation. They have got so many informations, so many, whatever product they have, they want to sell. But as a buyer, we have to consider all those extra expenses. And this also should be included once the project is started. Once the plant is started, then the already the profit is hand to mouth only. So afterwards, you cannot spend more money on that. So you have to take care as a buyer to include all items, because it's a coal and lignite or mostly government. They feedstock cost is fixed, transport cost is fixed, though it is a pitted item plant. The cost, all costs are to be included. Seller side, whatever equipments they are manufacturing, plus logistics, everything should be included. Finally, you have to work out the economics. Then only it will be economically viable. Otherwise, if you calculate all equipment side utilities, steam, nitrogen, water, and all other aspects, if you include, the cost will go up higher, on the higher side. So finally, it is not matching. That is the thing. Always there is gap from buyer and seller. We should try to reduce the gap. The seller should go up, should do some compromises. Similarly, buyer also should do some compromises. Then only the project will emerge. Okay. So I am going to explain the gasification, combustion, drying. What is gasification chemistry? What is different type of gasification process? What is the different type of gasification equipments, technologies, and then leading global suppliers, coal gasification and lignite gasification. Bed materials. Bed material is another gray area, catalyst, what we are going to use in the process. Those areas, OPEX will be more, because the bed material may, the life period of the bed material may go at any time. Though they have scheduled the life period, it may go out earlier. Because of that, the OPEX will get increased. Similarly, catalyst. Catalyst life, you cannot predict. Though they have beautifully present with some life period of 2 years or 3 years, it may go out within a year. You cannot predict. So those things, OPEX will be definitely increased, which will erode the profit. And another thing, material balance and energy balance should be properly worked out so that you can ensure the optimization of the process. Always you should create comfortable situation for the operation people. Without knowing the intricacies of the operation, they cannot run the plant. There should not be any uncertainty while running the plant. Operation people, they have their own problems, erosion and corrosion problems, heating economics. You can save energy. So energy efficient, introducing the introductions, heat exchange, introduction of heat exchangers at proper places, and saving the energy. And another point is pollution. You try to reduce the pollution. Try to reduce the pollution at the bottom. Try to reduce the pollution at the top. So efficient operation is a key of success. They have to do it. And so the difference between the combustion and gasification. Most of them know the basics. However, I will read out what is given in the combustion and gasification in this slide. Chemical process means it's fully oxidized. Gasification means partially oxidized. Chemical environment, oxygen, it is oxidizing environment. This is oxygen reducing environment, gasification. Primary product is nothing. After combustion, you will get only rejects, ash, no fuel value. This you will get syngas. And downstream process, you will get electric power. You will get the chemicals and the liquid and other items. Current application dominates coal-fired power generation worldwide. So mostly these are chemicals, fuel, power, and generation downstream side. Efficiency 35 to 37%, higher heating value. This is 39 to 42% higher heating value. So emission is new source pollution standards. This is NSPS. So this is a combustion, there is a figure, and gasification also there is a figure that should be followed as per the norms stipulated by the Pollution Control Board from time to time. So CapEx approximate cost is arrived. They know combustion side. Gasification side, it needs to be improved. You cannot do R&D, basic R&D in the while commercializing the gasification. Already they should have some experiment, and coal gasification already it is there elsewhere. But lignite gasification suitability, everywhere lignite is different from one place to another place. Even Neyveli lignite is different from Rajasthan lignite. So the feedstock has to be studied. The lignite, if you take it, approximate analysis, ultimate analysis, heating value matters, and then ash fusion temperature, ash chemistry of ash. So those informations are hot grindability index. Coal hard HGI is very strong, less number, and lignite HGI is high number, but it is not strong. It is like sand mass. The HGI would have been 120, whereas coal HGI is approximately 60. In that way it happens. So the chemistry of the coal and chemistry of the lignite has to be studied. Kinetics of the coal and kinetics of the lignite has to be studied. Then only, and fluidization. Fluidization is another important subject. That fluidization velocity. You have to keep the material and admit air, and a particular velocity, the material will flow, that fluid condition. That velocity has to be, do the experiment and find out. That fluidization, with that only, you have to design the fluidized bed gasification. Otherwise, the material will go to along with the flue gas. So these points are to be studied at the pilot plant. You know, briquetting and carbonization plant, they have started in 1966 only, but they have already installed the pilot plant in 1957, and they have done a lot of experiment in the pilot plant. And after generating the data only, it is available in the net. Based on the data only, they have established the commercial briquetting and carbonization plant. So either you prefer the choice, because directly if you invest 5,000 crores or 7,000 crores and do experiment directly at the commercial area is very difficult. It will lead to a lot of problems. Instead of that, limited amount, you can do it in the lower scale, pilot plant scale, and find out the informations. Based on the availability of the data, you can expand the project into the commercial one. Otherwise, if the firm claims they have the facility at their place internationally or in India, let them quote their facility, whatever the facility they have. We can move our feedstock and do the experiment at their facility and generate data, confirm the comfortability of the operation of the system. Once those parameters are arrived with optimization, based on that only you can proceed further. Otherwise, it will be very difficult. what is the reaction? Chemistry of the process. Gasification with oxygen is nothing but carbon with oxygen gives rise to carbon monoxide. So this much heat is released. Combustion with oxygen is complete combustion, 14 BTU pound per pound degree centigrade. That heat is released. Gasification with the carbon dioxide, C plus CO2 will give rise to 2CO. These are all the reactions which are happening inside the gasifier. Gasification with the steam, C plus H2O gives CO plus H2. CO plus H2 is syngas. So carbon monoxide and hydrogen, the ratio decide the final product. The ratio normally for diesel, the ratio should be 1:2. So based on that, they use water gas shift reaction. With the water gas shift reaction, they increase the quantity of hydrogen and they decrease the quantity of CO. That is why it is called water gas shift reaction. Using that, they will fix the ratio based on the requirement of the final product. They will do the water gas shift reaction accordingly. Then gasification with hydrogen. Carbon plus hydrogen will give rise to methane, CH4. Water gas shift reaction I have explained. Methanation. Carbon monoxide plus hydrogen gives CH4. This is the chemistry of the process. So this is the gasification setup. How the coal is gasified. Coal with the external steam and oxygen for firing. So this coal will fire. So coal will, you can gasify the coal. A retort is required. So there are three types, major types. One is fixed and moving bed. Another one is fluidized bed. And the third one is entrained flow. Fixed bed means it is a solid material. You have to compact, or already if it is a solid, then no issue. So in the vertical retort, another point I would like to explain, the process, there are three types of process. One is upward draft, another one is downward draft, and the third one is cross draft. So based on the requirement, the technology will select the process. And fixed and moving bed is, we use solid for gasification. Fluidized bed means powder material. That powder will get fluidized and then gasified. Entrained bed means it will become a slurry. Totally the material will be ground, fine material, and water will be mixed. The slurry is made to pass like liquid fuel. So this is the entrained bed. Entrained bed is generally costlier. For higher ash content, coal is having 30-35% ash. This entrained bed may not be suitable. For lignite, fluidized bed is more apt. Entrained bed is comparatively costlier affair. The cost will be more if you employ entrained bed. But in the entrained bed, the temperature and the pressure are more, higher side, and the conversion also will be high. Perfection will be more, but the capex will be more. So you have to select the process based on your requirement and feedstock. If the capex is more and your initial investment is more, after working out if the product profitability have to be worked out, it should be, we should ensure there should be some profit. So mainly the equipment cost will decide the success of the project. Entrained bed gasification. So this you can see coal, water slurry at the bottom, oxygen from at the bottom, and you will receive gas and slag at the bottom. Coal, water slurry, and oxygen at the top. The graph, y-axis is the retort, the entrained bed gasifier from top to bottom. 0 means bottom, and the top one is coal, that area that is top. And x-axis explains the temperature. you can see the variation of temperature. The graph shows the height, particular height. If you see what temperature variation of coal and oxygen at different height is shown in the temperature. This is entrained bed gasification. Mainly what I have explained. Feed and oxygen enter into co-current flow. The high temperature operation requires with the high oxygen demand for these type of processes. Size is 100 micrometers to promote mass transfer and allow transportation of solid using gas flow. The key characteristics of entrained flow gasification is very high and uniform temperature, usually more than 1000 degrees centigrade, and very short residence time. Fuel within the gasifier. Because of the high temperature, very high conversions are possible. Ash is withdrawn in the molten form. Solid fed into the gasifier must be very finely ground and homogeneous, which in turn means that entrained flow gasifier are not suitable for feedstock such as biomass or waste, which cannot be readily pulverized. And as a lignite is having low ash fusion temperature, if ash slag is more, we may find it difficult if we use entrained bed gasification. At present, so many offers we have received based on entrained bed gasification that should be properly studied. Then only you can move forward further. And some commercial global suppliers I am giving: GE Energy, and this is E-Gas, Shell, Siemens, MHI Airborne, Eagle. These are all the companies which are supplying entrained bed gasification technology. So next one is fluidized bed gasification. This is cost-wise less, and you see gasifier top, bottom, and x-axis the temperature, variation of temperature of coal and gas along the passage through gasifier. Particular height, if you see coal at 250 degrees centigrade, here it gets increased at this height, and the dotted line shows gas. So gas from the bottom, if you see 250, it gets slowly increased and reached 900 degrees centigrade. So this fluidized bed gasification, what are all the points need to be discussed? Size of the particle is critical. Size of the particle is critical. Fine will tend to entrain in the syngas and leave the bed overhead. Fluidized bed steam mixture which promotes both heat and mass transfer. It ensures an even distribution of material in the bed, and hence a certain amount of probably reacted fuel is inevitably removed with the ash. This is partially captured in cyclones and returned to bed. Fluidized bed, the upgraded version is circulating fluidized bed. So whatever material escape at the bottom, at the top, that another equipment is there, one vessel is there, which trap the dust like material, and it is sent to the bottom again for the recycled. That is why it is called circulating fluidized bed. This places limitation on overall carbon conversion in fluidized bed process. This type of gasifier is suitable for reactive feedstock such as low rank coals and biomass. So lignite fluidized bed is suitable for lignite material. Fluidized bed gasifier generally operates below the ash softening temperature because ash slagging can disturb the fluidization of the bed. So there is similar. We have already experience in fluidized bed combustion in thermal power stations. That is complete combustion. This is incomplete combustion. So all parameters, all operations are almost similar. So we have experience in that area. So because lignite is fluidized bed combustion is suitable for lignite, they have decided, and with the help of BHEL, fluidized bed combustion thermal plants have been installed. sir. So what happened? The plant was operated at 1100 degrees centigrade. Due to that, ash slag formation at the bottom and further withdrawal of ash has become a problem. So after 15 years, they have reduced the temperature from 1100 to 980 degrees centigrade with the consultant advice, and afterwards that problem was solved. But incomplete combustion they have experienced 40% carbon in the ash. That is why they could not run the unit. They have stopped and they have switched over to oil gasification. This was like a steel unit in NLCIL. So now with the modifications and latest technology, this also can be studied, how to use this technology. Now RWE Germany, they only take up this work, Winkler gasifier, and they have modified and they have supplied to many firms. 1960, 1970, 1980, they have a lot of RWE plant were installed elsewhere in the world, and they have now another company has purchased this technology and they are doing it. So BHEL, KBR Transport, Greenpoint Energy, Winkler UGas, they are pioneers of field fluidized bed gasification. In addition to that, other companies are also there. Just I am quoting the main companies. So we have to explore the global suppliers, and based on the discussions, further steps can be taken. This is moving bed gasification, what I have explained in the BNC plant. So it's a solid-like material fed from the top. So first stage is drying, devolatilization, then gasification, then combustion. So at the bottom, ash slag is there. Oxygen and or air is admitted at the bottom. It will travel upwards. So gas is taken out at the top. So if you imagine this is a gasifier, a graph. So coal, at this height, what is the temperature of coal? 250. At this height, what is the temperature of coal? 500. Like that. Gas. At this height, how much gas and what is the temperature of the gas? That you can view. At this height, you can see the ash. Afterwards, only ash. 1000 slowly, and while withdrawing the ash, it is only 500. Moving bed gas solid flow patterns. So moving bed gasification. Coal which enters at top moves downwards through gravity is gasified by the upcoming counter current air or oxygen and steam mixture. The hot synthesis gas from gasification zone is used to preheat and pyrolyze the downflowing coal. With this process, the oxygen consumption is very low, but pyrolysis products are present in the product synthesis gas. This gasifier operates on lump coal and outlet temperature of syngas is generally low. This concept was supplied by Lurgi in our briquetting and carbonization plant. Based on some 9 carbonizers were installed, and always 8 carbonizers they were in operation. 1 is kept as spare. Mark IV gasifier. This is a latest version. Now what they supply. This is the companies working in the field of moving bed gasification is Lurgi, Dry Ash, British Gas Corporation, and other companies also there. So this is a Great Plains Synfuel plant. So this is, it is situated in United States that manufacture natural gas 160 million cubic feet of natural gas per day. It is a biggest plant, one of the biggest plant. 1984, installed in the year 1984, using the Lurgi process, the plant gasified coal to valuable gases and lignite and liquids. Sorry. So slurry licensed pet coke, whatever experience, air product interested in carrying out syngas production from lignite, they express their interest and they are doing discussions are on with NLCIL, and they experienced what they have had. So they have supplied some few plants to so many countries, which is listed here. 50 coal feed gasification plant are licensed and 35 plants are currently operating and 7 in various EPC stages. This is the status of air products. So Lurgi, it is a raw material, then syngas purification. Then what are the requirements? Dimethyl ether, methanol, nitrogen, that process, whatever material you require, that process has to be followed. Final product is carbon dioxide, hydrogen, chemical, fertilizer, synthetic natural gas, power, syn fuel, syngas for DRI, direct reduced iron. So Lurgi is having this kind of technology. Their experience, wherever they supplied Jindal Steel Plant, India, and then Dakota Gasification Company, USA, like that they have also supplied and they have experience. So many gasifiers they have installed. Air liquid. This was Lurgi. Lurgi name is now Air Liquid. This is e-gas. How they traveled. First bench scale, then prototype, then LGTI, then washed base river. 36 tons per day initially, then 1,600 tons per day. And from 87, 2,400 tons per day. Like that, they have increased their capacity based on their experience. Lignite, they have handled lignite, they have handled subbituminous coal, they have handled bituminous coal. Like that, they have a lot of experience. So this company also can be discussed, called and discussed. This is BHEL. They have 4 type of facilities. 6.2 megawatt IGCC with moving bed gasifier. Then Pedu pilot plant based on PFBG. Then 6.2 megawatt IGCC retrofitted with the PFBG. Pulverized fuel. That is a PF. Advanced fluidized bed combustion. So these 4 plants they have installed at their place, and they do testing. They with our feedstock, and they generate data and they give. This is tons per day. Gasifier coal capacity 1.2. This is available in Hyderabad, semi-pilot scale, ARFBG. Now we have supplied some 8 tons lignite to the Hyderabad BHEL, and they are carrying out some experiments, fluidized bed gasification. That study they are doing. Now they have taken up already with the Coal India. So now after completion of Coal India study only, they propose to take up this work, lignite based gasification study. Then Pedu, 18 tons per day. PFBG, 168 tons per day. It is in Visakhapatnam, 160. This facility is available in Visakhapatnam. Gasification history. There are more than 272 operating gasification plants worldwide with 686 gasifiers. There are currently 74 plants under construction worldwide that will have a total of 238 gasifier and produce 83 megawatt thermal. 33 gasification plants are located in the United States currently. China has the largest number of gasification plant now. So this is the geographic region. Based on the gasification capacity, Asia, they have 50,000. The green shows the operating plant. Asia region, they have more than 50,000 megawatt thermal syngas production units. Africa, they have approximately 25,000. Europe, still less. America, still less. South America, very minimum. Construction yellow, showing yellow, and plan. Whatever now they are planning, that is shown as blue. This is 2018, based on 2018 data. I have attended gasification conference in 2013 in India, 2014, 2019 also. But the 20 also it is available. I collected those informations. Whatever I am giving in this slide or based on the informations I referred from the material given in the gasification conference. This is gasification by application, where it will be what product we are going to make from syngas, chemicals, liquid fuels, power, gaseous fuels. So you see 60,000, more than 60,000 megawatt thermal it is running. Liquid fuels 20,000, more than 20,000. Power 10,000. Gaseous fuel around 5,000. So in that way, you see yellow, you see blue. This is the application side information, worldwide, world scenario. And this is based on the feedstock. We have coal, we have petroleum, we have natural gas, we have pet coke, we have biomass, we have waste, other waste. So using those material, how much we are producing? Gasification, syngas. Coal is a major player. Conventionally, coal is a major player, coal bar lignite. And others are comparatively less. 400 number of gasifiers, coal, based on coal. Petroleum, it is almost 50 only. So this is 2019 data. And market trend, 1950 onwards, how much megawatt thermal syngas is used, produced and used. That is that slowly we have increased the capacity, and 2018 now 1 lakh. We have reached 1 lakh. So this is the scenario, worldwide scenario for the past 70 years. Yellow is construction and blue is planned. It is under planning. So, challenge of high ash coal, choice of gasification technology. I have told already, lignite fluidized bed gasification is more preferable. Entrained bed, you can verify, you can do testing and confirm. Then only you can do scale up. Combustion side, fluidized bed combustion side, fluidized is selected. It is proven. So it is a safe game we are playing. So more number of thermal based on lignite is set up. But gasification side, it is not planned. It is not a safe game. You have to do lot of homework. All points should not be omitted. Though there should be some argument between buyer and seller, a common understanding have to be reached. But seller also, I request seller also have to cooperate with the, because coal and lignite, mostly they are government companies. They are trying their level best to accommodate how to proceed, how to install the plant, alternative energy source. They are seeking lot of avenues. So they should consider those points, and they should join hands and supporting the Coal India and NLC for the success of the gasification plant. Already it is in other countries, China and other countries, a lot of gasification units have been installed. They are progressing like anything. In India also, we should do, so many avenues are there. We should march forward. We should make a pathway for introduction of syngas. Syngas is the main raw material which will give fuel, substitute for fuel. Already we are importing a lot of diesel and petrol from oil Gulf countries. So that import substitution, this should be encouraged. And gasification economics, if you see the requirements, is ammonia, hydrogen, methanol, ethanol, what is the ratio? It is 3. Ammonia means nitrogen by hydrogen. 3. Carbon monoxide, hydrogen by carbon monoxide for hydrogen. Methanol. Like that. Syngas means H2 by CO is equal to 2. Like that. So this capex and opex is given clearly. Some requirement, capex is more. You just see catalyst and other thing, opex will be more. Efficiency of syngas. You have to concentrate, invest some amount. Where are the areas opex will be more? That should be considered. With the capex and opex only, you can arrive the cost. That will be the more opt calculation for arriving the profit. If you omit anything, then the profit will be eroded. Consider all informations, all points, safety point, fire point, and environment point, and all other facilities, utilities, nitrogen, steam, air, everything. Don't leave anything. You put it in the nutshell and include all informations in the project, all points in the project, and work out and arrive the production cost. That will be more opt. Don't compromise anything. That is my request. Worldwide gasification capacity is expected to grow significantly, with the primary growth occurring in Asia, primarily China, India, South Korea, and Mongolia. Thank you, sir. Sir, I may, with my experience and with my observations and knowledge, I have present the gasification technology. It is an ocean. It has a lot of information. I have touched a little, and an awareness have to be created. That I want to do that. That is why I have done. I thank all the participants who have listened my observations and encourage and recognize me. Thank you very much. If you have any clarification, if you want to throw some light, we are ready to receive, sir. And any query, if not answered now, will be answered afterwards. Thank you,
sir.
Thank you, sir.
Sir, I have one question, sir.
Okay. Sir, your name, sir. You please.
I am Annadurai from Trichy.
Okay,
I am
sir.
Annadurai from Trichy.
Okay, sir.
Sir, you have started your career with biomass, right, sir?
Yes, sir.
Briquetting and all.
Yes.
As far as I know, India has high potential for biomass gasification process.
Yes,
but
sir.
I don't know why it is not picking up, and it is also economically viable. I have visited some gasification plants, biomass gasification plants.
Yes, sir.
It is also economically viable as far as my visit was concerned. But then why it is not picking up in India, sir?
Sir, the problem is you see now farmers, the same case, non-conventional energy means it is not corporate. It is a small scale industries. Many small scale industries, they have started the project. Though the production side, it is okay. Marketing side, it is very difficult. You cannot fetch the fixed the price what you want. That is a problem. The takers are less, and we cannot sell the product at with loss. You know what happened? When we 700 companies, similar companies, we have started all over India at the start during 80s, and almost all companies have failed. And we have made representation with the ministry, Delhi. Very surprisingly, they have a right of the interest and asked us to pay only the principal. So based on that, we have paid the principal and we came out. That was a thing happened in 80s. If they support in taking up the product, if a marketing solution is there, some solution for marketing is there, definitely the fuel substitute can be achieved. The Begasi pith and rice husk, it has some 5,600 kilocalories per kg. The product was very good.
Thank you, sir. Thank you.
Thank you. Thank you.
And Gopal.
Yes, sir.
And Gopal.
Yes,
Mr. Natarajan, Mr. Annavara clarified now what I got the latest information.
Okay.
The Indian Oil Corporation is encouraging compressed biogas,
Okay.
which is produced from the biomass. So a lot of plants are coming up. They are even making an agreement for purchase of the biogas, compressed biogas,
Okay.
which they are selling through the Indian Oil Corporation outlets.
Oh.
So there are a lot of projects are coming up in India now.
They are
Maybe
expecting support. Welcome, sir. Gopal, sir.
Yeah, yes.
You throw some light on the gasification side. What is the current status?
Current status. So no. Current status. Say current status. If you see, the major player is only air products.
Yes, yes.
Air products. They are preferring now not the slurry based, because slurry is less efficient.
Yes.
Efficiency is less.
Yes.
So they are preferring a dry feed,
Right.
like a grind, like a fine powder, like what we are doing in a boiler milling. So
Okay.
same do the milling and inject in the like in a boiler. So it's a slagging type. That means temperature of the gasifier will be above the aspiration temperature. So ash will fuse and form like a slag. So it will be taken at the bottom. That is what their process is involved.
Okay.
Slurry, it's less efficient. That's what they are telling. As you told, we have to do a lot of base work. We find out the data from them, which is a better. But they are preferring dry feed. That's
Dry
what I understand.
Okay.
Coal now, the tender is now due for opening this month from the Coal India. Which
Okay.
they given already, tender has been given. The tender opening date is around this, maybe after a week or so. They given a build one operate basis.
Yes, sir.
So how many players, how many quotes they are going to get, that will be a good idea. So how many, because most of the gasification technology providers are all out of business now. Because past 30, 40 years, nobody is doing it other than China.
Okay.
Either Europe or India, nowhere gasification, even Australia, nobody, because all lignite and coal they are just closing down. Even Germany in the 1960s, 70s, there was some gasification plant, it's all not operating. Only in China now. Except China, nowhere gasification is operating. So most of the gas, if you see the gasification in China, they have their own technology they have developed. And some places, there are some air products. Air products, nothing but a cell and G. Both the technologies have been taken over by air products. So this was the status. Anyway, when the NLC gets some technology, express some interest, we'll get a more idea who are all in the field, who are all in the market.
No,
will come to know.
they have to consider. No, they have to consider lignite feedstock.
Yeah,
Different from coal.
China, they have done it. China, there are some lignite feedstock is available. In Inner Mongolia, China, one of the province, Inner Mongolia, they have done some lignite gasification for methanol also they produced.
Now, two negative points. One is spontaneous combustion. Another one is it is highly reactive.
Yeah,
So those 2 points have to be considered. It is totally contrary to the coal.
Yeah.
And based on that, the study has to be.
Yeah, but they have some plant in China which we have to see. They are already operating plant.
Okay.
But as you told, we have to compare the lignite property of that plant, lignite property of NLC. Then we have to compare how it is different.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Yeah, but that compressed biogas is a lot of is upcoming. Good potential is there. Government of India is promoting a lot of compressed biogas plants, CBG, called compressed biogas from the biomass. And Indian Oil Corporation is taking a certain price they are fixing. They are getting marketed by IOCL.
Oh, marketed by IOCL.
Yeah, marketed by them. They are fixing the price also. What price they will get per compressed biogas. So if you have a biomass locally, we can produce and sell it the nearest point.
Good. Thank you.
Okay.
Sir, any other views are welcome. That is a different subject, sir. Surface gasification only I am now explaining. That is a very big chapter. Sir, the thing is, underground coal gasification. Some consultant from Russia, they have approached us, but the cost is very high. Number one. Number two, Russian companies they are finding it difficult to submit the experience. They don't give experience like other countries. So we cannot. There we find it difficult to select them, and the cost is also very high. But it is not proven. We cannot because underground means anything may happen. Unless service we are assured we cannot proceed.
Mr. Nataraj?
Yes.
Underground gasification, one Australian company, they are already building the plant. It's going to be commissioned shortly.
Okay.
They are building an ammonia plant.
Okay.
The gasification, underground gasification, and the nearest from that same area where the mining area is there, they are building a large ammonia plant.
Okay.
Yeah, it's already under construction. We have to see. Maybe another 1 or 2 years will be commissioned. That will be one of the first plant. Yeah.
Where it is located?
I think somewhere in Victoria or something like that. I will let you know the details. I got some information.
Okay, sir. Okay. Sir.
Plant is already under construction. The company name also I remember. I will let you know. I don't remember now. They are given a presentation also.
Any information this kind of welcome, sir.
Yeah, sure. I will share with you.
Okay. Sir, any other views? And only you will clear the misunderstanding. You may have your own views. Mainly cost economics only it is not matching. Most of because I have traveled 10 years for this gasification of lignite from 2010. I talked to some 3 firms every 3 years. Finally, it ended with some non-acceptance because of the commercial conditions.
Good evening, everybody. So far, we have witnessed a very good lecture from our renowned chemical engineer who has put more than 2 decades, 3 decades of service from CARD, Center for Applied Research and Development. He has delivered a very good lecture, informative, knowledgeable. Finally, to add a feather to the cap, he was prized by our beloved director, PNP NLCL, IE Honorary Chairman, Neyveli Center, as well as patron of E&SA. He was prized very much by the eminent personality. So, on behalf of both forums, I like to thank our faculty member, Engineer T.D. Nadraj, as well as the participants who have joined through webinar and the prize winners of the quiz competition on this occasion. Thank you very much. We will meet again in the next meeting. Thank you.
Sir, Swami sir, can you hear me?
Yes, sir. Yes, sir.
Sir, NLC is exploring the possibility of putting up a gasification plant. For that, they started working. So many firms have approached NLC and it is going on, sir. It is in process.
So far, it is not started because of the capitation investment, sir.
No,
Due to high investment in the gasification plant, they have not done so far, or any other reason?
They have to find the suitable technology. Coal gasification, already it is established elsewhere in the world, but lignite gasification, still it requires suitability. Some customization is required with respect to NLC lignite.
Okay. Then what about your urea plant, sir? Long back it was running.
Sir, urea plant and BNC, briquetting and carbonization plant, it was closed 2000 to 2003. By 2003, urea plant was also closed. The BNC plant was closed in 2000 and urea plant was closed in 2003. That is because of the conditions on those days.
Okay, sir. Thank you, sir.
Thank you very much.
Dear friends, I think sorry for the interruption for the other people, those who have not received the prizes and waiting, joined from other places. The program went on well because of all of your presence and patience also. Thank you very much, all the participants, particularly those who joined from other places. And again, this is not going to be another vote of thanks. Now the program is going to end formally. We will end the program now. Thank you and good night.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.